Hello friends, welcome to Risingpearl.com. We are talking about series 3, learning a lot about trigonometry. This is webisode number 6 and today we are going to talk about solving problems related to trigonometric ratios of an angle. This is our part 2. We started on webisode 5, last webisode, that was our part 1. So friends, let's continue to look into these questions. Before that, I want to take a moment to refresh what is meant by trigonometric ratio of an angle. As we saw in our webisode, I think it was webisode number 3, where we learned about what are these trigonometric ratios. So I have drawn a triangle ABC and I have arbitrarily assumed angle B to be 90 degrees. So then one of the acute angles, angle A, so I have expressed all the relationships or all the trigonometric ratios for angle A. I could have done that as well for angle C. So sine A is opposite side divided by hypotenuse. Let's write this. Every single opportunity that we get, we must write this to really clarify and cement these ratios in our mind. So sine A, if this is angle A, sine A is BC divided by AC. So that will be BC divided by AC. So cos A will be adjacent side AB divided by AC, adjacent side by hypotenuse. So it will be AB divided by AC, hypotenuse. Tan A is opposite side divided by adjacent side, BC divided by AB, BC divided by AB. Cosec A is the reciprocal of sine A. So if sine A is this, cosec A will be AC by BC, AC by BC. Similarly, sec A is reciprocal of cos A. So cos A is this, so sec A will be AC by AB, AC by AB. And finally, cot A is reciprocal of tan A, so it will be AB by BC. It will be AB by BC. So friends, now one other thing that I wanted to highlight was whenever we did any question or problems on algebra, whenever we had unknown amount, unknown quantity, the convention was to represent by lowercase letter x. If you would recall friends, whenever in algebra we do not know a value, we assume it to be x. Similarly, in the world of trigonometry, we use, whenever we don't know an angle, angle A or angle B or angle C, we represent it by this symbol, and this is called theta, Theta. It is pronounced as or spelled as theta, but we represent it by this symbol, theta. So I could have said this angle is theta. If this is 90 degrees and this is theta, then this angle becomes 90 minus theta. So just wanted to highlight this to you because the questions we are going to take a look at today, you will see theta, and I wanted to make sure that you understand what is theta. So that's it friends. Now let's take a look at what kind of questions we have seen earlier in the past for trigonometric ratios. So we have seen these kind of questions. One trigonometric ratio was given, right? What are the other ratios of the same angle? How did we solve these questions? We went with this strategy that if one ratio is given, it means that two sides of a right triangle are given to us. It should be two sides of a right triangle are given. And we know what we mean by this. It means two sides are given, but not really exactly. The ratios are given, right? But we can represent the exact sides in terms of some other real number. And we'll see this exercise. We saw this a lot in our last webisode as well. If two sides are given of a right triangle, then we can apply Pythagoras theorem and find out the third side. Because remember, in any right triangle, if two sides are given, we can find out third side applying the Pythagoras theorem. And then if I know three sides of a right triangle, I can write all trigonometric ratios. So let's take our first question. So say this is a question 1. Sec theta is given to be 13 by 12. Find all trigonometric ratios. So what do? First we draw a right triangle, and draw right triangle whichever way you want. And now, because it does not say sec A or sec B or sec C or any such letter, so we can really arbitrarily name our triangle also. And now we can assume any angle to be theta. If I assume this angle is 90 degrees, then I will assume one of the other two angles to be theta. Remember, in the last webisode, we talked about unless and until it is given that certain angle is 90 degree, we are not going to assume unknown angle to be 90 degree. So here let us just simplicity's sake assume this is theta. So we will say let our angle A is equal to theta. If this is the case, what is given to us? What is given is sec theta is equal to 13 by 12. And like we did in our last webisode, we would want to express or try to find out the ratio sine or cos or tan, because the cosec, sec and cot are really the inverse of sine, cos and tan respectively. So if sec theta is this, so cos theta will be 12 by 13. 12 by 13. Now if we assume angle A is theta, then cos theta will be how much? Why cos theta? Because cos theta is 12 by 13. So here cos theta will be which two sides? AB by AC. Now if this ratio is 12 by 13, this is, friends, what we mentioned earlier, that whenever any ratio is given, if one ratio is given, it means two sides are given. And by that what we really mean is we still don't know the exact dimension of BC, or in this case AB and AC. We do not know the exact dimensions, but we can assume that AB can be, let us say, 12k. What is k? K is any positive real number. If this is 12 times k, then this automatically becomes 13 times k. Why? Because the ratio is this. Why cannot I write AB equals to 12? Because AB, the exact dimension, can be 24, right? And AC actually can be 26. Imagine if these are the two dimensions, this ratio is still 12 by 13. Or AB could be 12 times 3, which is 36, and AC could be 13 times 3, which is 39. Right? The actual dimension could have been 36 by 39. But again, this ratio is 12 by 3. Because we have a ratio, we do not know what is the common factor, which is, for both of them. It could be 1, in that case it will be 12 and this will be 13. But if it is 2, this becomes 24, this becomes 26, as we saw. So similarly, so we can assume that k could be any positive real number. So we can express AB as 12k and we can express AC as 13k. Now I have a right triangle ABC and I know two sides. So applying Pythagoras theorem, I can find BC. So let's write it. So applying Pythagoras theorem, AC square is AB square. It is AB square plus BC square. BC is my unknown side, or from here we can write this as AC square is 13k, AC is 13k square, AB is 12k square plus BC square. Or from here this implies BC square, we can write BC square as 13 square is 169 k square, and if you take 12k square on the other side, it will become minus, plus will become minus. 12 square is 144 k square. This will be 25. If you do the subtraction, you will get 25k square. So from here, BC, we will do square root of both sides. BC will be equal to plus 5k. Because the minus 5k doesn't make sense, because BC is the length of a side of a triangle. It cannot have a negative value. So BC is equal to 5k. So this length is equal to 5k. Now that I have three sides of a triangle, albeit expressed in terms of k, which is a positive number, I can find all of my ratios. So first of all, sec theta is this. So we know cos theta is this, right? Let's find out sine theta. Let's write it here. So sine theta will be how much? Because we assumed angle A is theta. So sine theta is BC by AC. So let's write the ratio BC by AC. AC. BC is 5k. AC is 13k. So k and k will cancel out. I'll get 5 by 13. So if sine theta is 5 by 13, cosec theta will be reciprocal of this. So cosec theta will be 13 by 5. Similarly, let's do the tan theta here. We are really running out of space here. So tan theta is equal to, if this is theta, tan theta will be BC by AB. BC by AB, or let us just create some separation for us here, or BC is 5k and AB is 12k. Again, k is a positive number, it can cancel out, it will cancel out. 5 by 12. So tan theta is 5 by 12. So cot theta will be reciprocal of tan theta, that will be 12 by 5. So friends, we have found out all the 5 other ratios of the triangle of the angle theta. Let's take a look at one of the question. Now here cot theta is given to be 7 by 8, and we need to find, the question has two parts. First one, we want to find the value of cot square theta, and then second we have to find out the value of a big expression. So how do we solve this question? So what we are going to do, friends, is that we have drawn a right triangle, and just to change it up a little bit, I have put this vertex as C and this as A. But I'm going to assume this as theta. In this case, I'm going to assume that angle C is equal to theta. I'm going to go with this assumption, and you will see why we are doing that. It doesn't really matter if I take this as theta or this as theta, because it is just easier if you have this. Then we can really visualize what side is opposite. So it will just help us write the ratios a little bit more easily than, let us say, if we were to assume this angle is theta. That's all really is there to it. Now let's do one thing, friends. So here in this case, so how do we solve the first part? How do we solve this part of the question? Well, the way we can do this simply is, before we come here, the way we can actually look to solve cot square. So what is given to us? What is really given to us is, we know cot theta, right? So cot theta is equal to 7 by 8. So what is this question really asking us? So cot square theta is nothing but cot theta square. This is very important to understand this, and we have discussed this earlier as well. So friends, essentially the trigonometric ratio cot theta, if you square that, it is also written as cot, then the square, and then the angle. So for example, if something is given to you as sine 5a, what this really means is that sine a, your ratio, whole thing raised to the power 5. It is very important for you to understand that these two mean the same thing, because sine by itself is meaningless. Sine is a ratio of an angle, so sine A is one thing, and that is raised to the power 5. It is more intuitively easy to follow this than this, but you need to understand that if you have the power given right after the ratio, it really means the same. So cot squared theta is nothing but cot theta squared. So now that you know it, cot theta is given to be 7 by 8. So we can do this. So this will be nothing but 7 times 7 by 8 times 8, or simply 49 by 64. So if cot theta is this, cot square theta is 49 divided by 64. So that was the easy one. Now let's look at this big complex one. Let's clean this up a little bit. Now here, friends, first thing is that we will try to simplify this first. I think we would still need to find out all the three sides, right? So let's do one thing. First, let's try to simplify this and see what we get from it, and then we will find out the three sides. So if you just treat this as a regular expression and you want to solve this, so you will write this as, this is equal to, on the numerator you have, think about it this way, this is basically nothing but, you have 1 plus sine theta multiply by 1 minus sine theta, and here you have 1 plus cos theta multiply by 1 minus cos theta. So this is really of the form a plus b multiply by a minus b. If you have this, this is really nothing but a square minus b square, right? So this will mean 1 square minus sine theta square on the numerator. On the denominator it will mean 1 square minus cos theta square, right? And so here, if I need to now find the value of sine theta and cos theta, so for that I need to really find out all the three sides. So let's go back. So what we have been given is cot theta is this, and we assume that C is theta, then tan theta is equal to opposite or reciprocal of this, it will be 8 by 7. 8 by 7. If this is theta, I can assume this side to be 8k, and then this side is 7k. So if I were to do Pythagoras theorem in triangle ABC, so I will get AC square, which is the one we need to find out. AC square is equal to 8k square plus 7k square, or this comes to, so 8 8s are 64k square plus 7 7s are 49k square. Or if you were to add this, I think we have to add it. So 64k, well, we don't need to really put the k square, plus 49, 64 plus 49. So 4 plus 9, 13, 1, 113. So it will be 113k square. So I have got 113k square. So from here we can say that AC then is equal to square root of 113 times k. So this value is square root of 113 times k. Now here, friends, so let's continue with our our question here. So 1 square is 1 minus what is sine theta? So if tan theta is this, what is sine theta? So we have to now find out the value of sine theta and then put it in this expression, right? So sine theta here is what? Sine theta is AB by this. So sine theta is actually 8 by square root 113. So I have to put that value here. It will be 8 by square root of 113. And I have it as square. And denominator 1 minus what is cos square? Cos theta. So if sine theta is this, cos theta will be 7 by square root of 113. 7 by square root of 113. And then if you were to solve this, so what you will get, this is 1 minus, so 8 square is 64 divided by 113, because square root of 113 multiplied by square root of 113 is 113. Denominator you will have 1 minus 7, this is square. 7 square is 49 by 113. So you just have to solve this fraction. So here you will get denominator 113, and then 113 minus 64 will be 49. And denominator you will get 113 here. 113 minus 49 is 64. So essentially this and this will cancel out and you will get 49 divided by 64. So this is the value of this expression. So friends, this is how you will, this is a second set of questions, second type of questions, whereby you are given a ratio and you are not only asked directly to find out the other ratios, but you are given some sort of an expression like this. You have to solve that expression. You have to simplify this expression first. And then you still need to find out the other ratios and put those values in your expression and then solve it the way we did it here. So friends, let's probably take maybe one more example. So here let us say that what we have is, say in triangle ABC, we have not been given the triangle ABC, but it is said it is right angled at B. Tan A is equal to 1 by square root 3. Find, and as you can see here friends, again another expression. So there are two questions. So first part is an expression I have to find, and second question is another different expression we have to find. So let's take a look at them one by one. So what we are going to do first is we are going to draw ourselves a triangle. This time when we draw the right triangle, we have to keep in mind that we absolutely want to have angle B as 90 degrees because that is given to us. And this is A, and tan A is given to be 1 by square root 3. So tan A will be this, right? So we can say if this is x, then this side is square root 3x. For the same reason that what is tan A? Tan A is equal to BC divided by AB. Right? So, and if this ratio, if BC divided by AB is equal to 1 divided by square root 3, then I can assume that, you know, the numerator is x. I could have written as k or a or any other positive number. X is a positive number. Then denominator is square root 3 times x. Now applying Pythagoras theorem, we can find out that AC square is equal to x square x square plus square root 3x square. If you do that, you will get x square plus 3 square, which is equal to 4 square, 4x square. So if AC square is equal to this, then AC is equal to 2x. If you do square root on both sides, you will get AC as 2x. AC as 2x. Now that we have this, here friends, look what we have to do. This is very important to understand which trigonometric ratio for which angle. First angle is for angle A. So I'm looking for sine angle A. So for angle A, sine angle A is BC by AC. This is really important for you to understand that. So this is BC by AC. This is sine A, BC by AC. Multiply by, the second one is talking about angle C. This is not cos A, it is cos C. So this is my C. So cos C will be which ratio? It will be BC. Remember, cos is adjacent side divided by hypotenuse. So cos C will be BC by AC plus, now going back to cos A. Cos A will be AB by AC, AB by AC, and sine C. So sine C here will be AB by AC. AB by AC. Why? Because sine is the opposite side by hypotenuse. So here now friends, we are going to just put the values. So BC by AC. So BC by AC is, let's just put it here. So BC by AC is 1 by 2. X and X will cancel out. This is also BC by AC. So it is really BC by AC square. Because BC by AC, BC by AC, we can say BC by AC square. Plus here AB by AC. AB is square root 3x by AC is 2x. So again X and X will cancel out. It will be this square, because again AB by AC, AB by AC. So here what we have friends is that 1 by 2 square, it will be 1 by 4 plus square root 3 times square root 3 is 3 by 2 square is 4, or this will be 4 is denominator, it will be 1 plus 3. So numerator is 4 by 4, or which is equal to 1. Cancel out 1. So really the value of this expression is equal to 1. So friends, here at this point I could have actually written these 4 ratios separately. Instead of representing these ratios here, I could have on the side written each of these ratios separately and then just put the value here. Pretty much the same thing. So friends, this is how here in this type of question you are actually asked to find ratios that involve two separate angles, A and C. It's very important to be very aware of what angles. Remember, from webisode 3 we have been saying whenever we talk about trigonometric ratios, it is always about a certain angle. So in this case we were asked to find an expression that involved two angles, not one. So we need to be very careful of, because depending on which angle it is, our ratios will change. So friends, I hope that you're following us along. In the next webisode we're going to take a look at some more questions on trigonometric ratios.